Alright, in today's video I'm going to do my best to explain to you how asynchronous programming works in Flutter and in the Dart language in general. So since I could not come up with an explanation of what asynchronous programming is, I'll use the definition I found in the Dart documentation. Dart code runs in a single thread of execution. If Dart code blocks, for example by performing a long-running calculation or waiting for I/O or input-output, the entire program freezes. Asynchronous operations let your program complete other work while waiting for an operation to finish. Dart uses future objects or futures to represent the results of asynchronous operations. To work with futures, you can either use async and await or the future API. So what does this mean? In simple words, if you're executing a long-running task, you shouldn't do it on the quote-unquote main thread, because that will freeze the whole UI, which would for a mobile application be terrible user experience. So if we have a long-running task, we will execute it on the async thread so the task can run on its own separate thread, and by that we aren't occupying the main thread, which means we won't freeze the UI. Okay, so before we jump into the app that we're going to use in order to demonstrate asynchronous operations, I want to explain a couple of concepts to you. First is the concept of a future. I will again use the official definition from the Dart docs to explain this. A future is a future of type T object, which represents an asynchronous operation that produces a result of type T. If the result is not a usable value, then the future's type is the future of void. When a function that returns a future is invoked, two things happen. The function queues up work to be done and returns an uncompleted future object, and later when the operation is finished, the future object completes with a value or with an error. So this means that whenever we need to execute an async operation, we need to return a future and give it the type of the result itself. If you don't understand this, don't worry, you will see this once we make the app and you will be able to see that in action. So here we have a default Flutter app, and let me just clean all this mess up so we can see all of this in action. Okay, so here I'll just add a text theme to our material app so we can see the text clearly when we create the UI later on. Alright, so here we are in our home widget, and over here we will draw a raise button and the text widget. Alright, so when this button is clicked, we want to simulate a long-running operation. That long-running operation is basically going to freeze the thread it's executing on for 3 seconds and change the state of our text widget. So let's declare a string property called result and set the value of our text widget to the result property. Alright, so here we have the result property. Let's just copy its name and go down to our text widget and set it over here. Okay, since we're going to mutate the state of our home widget, we should make this a stateful widget. Let's just go over here, convert to stateful widget. Alright, now we have everything set up and we can demonstrate how we would use an async operation. The first way we can use an async operation is using the future API. So let's declare a method called some long-running operation future API. This is going to be a fully synchronous method, and it will retrieve the result from a future using the future API. In this example, we're going to use the future.delayed method, which will just stop the thread for a certain amount of time and then return a result. This delayed method here is supposed to represent some long-running operation that we're executing. That operation can be anything. It could be an HTTP request, it could be your app accessing the database, you may load something from the local storage, it really doesn't matter. So let's now use that delayed method. Okay, but how are we going to get the result from this? We cannot just instantiate a variable and set it to this future.delayed because it's just going to return an unfinished future, but we can use the .then method from the future class to actually retrieve the result. The then method takes in one parameter, and that's the high order function that will execute once the future returns the result. So let's use that. Alright, so here we need to declare that high order function. Typically we'll get some sort of a result from future, and that means that the higher order function we're passing in also takes in a parameter which is going to be a result from the future itself. I declared the parameter over here, but I won't use it because the future.delay does not contain a result. But if you were, for example, running an HTTP request, you would take in a response and you would be able to process it inside this higher order function. Another convenience of using the future API is error handling. Because if the future returns an error, we can just use the catch error method and pass in a higher order function that handles it. As you can see, I'm here catching an error and just printing it to the console. Okay, and here in the body we can just set in the value of our result property, not to be confused with this result parameter, but the result property. We can set its value to be just done, so we can know that our quote-unquote long-running operation was successfully executed. For that we'll obviously use the setState method, and here I'm going to use this dot result because when we use just result, it by default looks at this parameter. Right, so here we just need to trigger this action inside our onPress method. So let me copy the name of the method and paste it over here. Alright, now let's run the app and see how this looks. Alright, so here's our app up and running, and when I click on this button, we're just going to wait for 3 seconds and see if we get the result that we desire. And as you can see, it says done after exactly 3 seconds. Okay, so as you can see, this is pretty nice and convenient when you have 1 or 2 asynchronous tasks that you want to execute. But what if you had 3 tasks and you wanted to execute the first task, and after that one is done, execute another, and after that second one is done, execute another one? Okay, so let's create a new method to try that out. In this method we're going to have 3 tasks that execute one after the other. They will change the value of the result property after every task so we can see kind of the progress. Okay, so let's write that code, and since I showed you this solution, I think you should be able to predict kind of what's going to happen over here. Okay, now as you can see, this is getting very messy and not really readable. But let's see if it runs, since that is the most important thing. Oh, and one thing I forgot to do is call this method instead of this one. So let me just paste the name of it over here. Alright, now let's save the app and go over here and click over here in the some long running operation. And as you can see, it should change after 3 seconds. It should say first operation is done, then after another 3 seconds second operation is done, and then after another 3 seconds third operation is done. So let's see how that goes. Okay, so this code works, but it's really messy, it's not very readable, it's not concise, and that is just some simple code of 3 operations. Imagine having a lot more complex logic. That would really be a nightmare. So now I'm going to present you another approach of working with asynchronous code, and that is async await. This approach is called async await because we use await to, well, await the future's result, and we can do it only in an async function. We make a function async by adding the async keyword right after the function signature. In the function we can get the result from some future using the await keyword. Optionally, you can just await a future without assigning it to a variable if you do not care about the result. So let's rewrite this method we just wrote just using the async await approach. Okay, so we'll do it in this function. Let's first make the function async so we can use the await keyword. And now let's write the code. Alright, now let's replace the method we used before in our onPress method with the one we just wrote. Alright, now that we have that, let me save the app and possibly restart it. So this method should do exactly the same thing as this one did, but we'll see. So let's click on some long running operation button. Alright, so as you can see it executes, but I kinda lied, it does not do the same thing, since over here I set it to be 2 seconds and up here I set it to be 3 seconds. But you get the point, if it was 3 seconds it would do exactly the same thing. So as you can see, this solution is a lot more readable than this one, but when you have just one operation you may use the dot then, you may use async await. There is really not a rule to it or anything, just your own personal preference. And I forgot to mention that there is one more difference when using this approach. You do not have built-in error handling, but you would have to use try-catch, just like in any other procedural code. Okay, but what if we wanted to write our own future? Well, that is very simple. Actually. You just want to make your function return a type of future and pass in the type of result you're returning. You will most likely want to make your future async, unless you're just returning in another future. When you want to return a result, if you declared your function as async, you can just return a result like any other function, even though the return type of your function is a future. Okay, so let's write a future that will just wait for 3 seconds and then return a string. Right, and now we can use this in our onPressed method of our bot. So let's go over here and paste it in, add a semicolon, and save and reload the app. Okay, so here's our app restarted, and when I click on some long running operation, it won't do anything we can see because this does not mutate the state of the widget in any sort of way. It just returns a result, but it's not displayed anywhere. So that brings us to the question, how can we use futures in our Flutter applications? I'm going to give you a simple example that is very common. So let's say you're loading a piece of data from the database asynchronously and you want it to be displayed in a text widget. You can do it by making the widget stateful and in the init state calling that future, and then in the result set the piece of that data using setState. This is valid but not the easiest or most simple solution. There's a much better approach, and that is using the future builder. Future builder is just a widget from the Flutter standard library. The future builder takes in a future as its parameter, and based on the state of that future you can build the widgets the way you want using the builder function that you also pass in. We'll use the future we created ourselves and display the result from it in a text widget. So over here I'll add a divider so we can differentiate between our two text widgets. Alright, so let's build out the future builder. So as we said, a future builder takes in a future. Over here the future is going to be the result of our function we declared down here, and the function is called myFutureOperation, so let's use that over here. And as we said, the builder is just a high order function that takes in two parameters, the build context and the snapshot. In the snapshot we can see if the future is done with executing, and we can retrieve the result once it's available. To check if the future is done executing, we will just check if the connection state from a snapshot is equal to connection state.done. So if our future is done executing, we will just return the text widget displaying a result from a future, and the result itself is located in the snapshot.data property. But what happens if our future did not yet return a result? Well, you should display some sort of loading. Over here I'll just display a circular progress indicator, but you can do whatever you want in your app. It's really your personal preference. Alright, now let me restart the whole app. So here's the app, loading, and it displays a result. And that's pretty much it for this video. I really hope you learned something new, I really hope you could understand what I was trying to explain to you. I think you should now be able to understand how futures work, how async, await works, how then works. And that's pretty much it. If you want, go follow me on Instagram. I like to interact with you over there, and you'll see updates about the new videos and whatever. And also, if you want to ask me some questions, definitely hit me up there or in the comments. It really doesn't matter. I check those often. And that's pretty much it. I'll see you next time.